Good morning, class. Welcome. As I mentioned before, that today our topic will be on slope of a line. We'll be finding the slope of a line taking just 2 points. We'll actually start from scratch by looking in the coordinate plane, the coordinate system, plot 2 points, and then use the coordinates of those 2 points and find the slope of the line through those 2 points. And then we'll also take the equation, like in the slope-intercept form of the equation of a line, and find an equation for that line through those 2 points. And we'll do so also using the point-slope form of the equation. And finally, we'll put that equation in its standard form. So let's start off, class, with 2 points in this coordinate plane. And if you look here, we have here in our coordinate system, I plotted 2 points. One in the first quadrant at x equal to 2 and y equal to 6, and another point in the third quadrant at x equal to -2 and y equal to -2. Now, what we'll be doing, class, is that we will be using the coordinates of those points and this formula for the slope of a line, which says that the slope m is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, which equal to rise over run, or is delta y over delta x, which is the change in y over change in x. Now, when you look at this and you see these subscripts, don't get scared by it. What these subscripts are is that they just identify which one of these coordinates you will use, because we have 2 points, and if you look at this one here, we'll call this one here x sub 2, y sub 2, we'll count that as 0.2, and this one here x sub 1, y sub 1, we'll count it as 0.1. And we will take those values, those coordinates, and substitute them into the formula, so we know where those coordinate goes. So it's there for convenience. Now, if we substitute, for y sub 2 we'll use 6, which comes from this point here, and for y sub 1 we'll use -2, which goes here, and for x sub 2 we'll use 2, and for x sub 1 we'll use -2. So let's go ahead and do that. Then our slope m is going to be equal to here 6 minus a -2 over 2 minus a -2. This -2 comes from here, and this is going to give us 6 plus 2 divided by 2 plus 2, which gives us 8 over 4, and that gives us 2. So you see what I've done, your class. I have taken those coordinates, put them in the slope formula, and I ended up with 8 over 4, which gives us 2. So that tells us that the line through those 2 points I talked about and show you has a slope of 2. Remember that these 2 negative here give us a plus, and the same things at the bottom there, 2 negative, we get a plus. Now, seeing that we now have, class, the slope of a line, we can go ahead and use another formula we have on this topic here, which we call the slope-intercept form of the equation of a line. This is just the formula. We know m, which is the slope that we just find up there, which is 2, but we don't know b. We have to find b. b is the y-intercept. So what we'll be doing is that if you know one point and you know the slope, we can use this formula here to find the equation for that line through that point. And we do know a point, and we also know the slope. So the point we'll be using is 2, 6. You can use the other one, x equal to -2, y equal to -2, and you should get the same equation. Well, I'll be using this one here. And if I do so, class, this is what I will get. I will substitute my 6 for my y and 2 for my x into the formula here. So I will get 6 is equal to 2 times x, x is 2, plus b. Alright, so then I will simplify now, and this gives me 6 equal to 4 plus b, and that implies that b is equal to 6 minus 4, and that gives me 2. So therefore b equal to 2, and that is the y-intercept. This is my y-intercept. So now I have here, class, the slope, I have the y-intercept, so therefore my equation for that line there now that runs through the point x equal to 2, y equal to 6 is going to be this one here. It's going to be equal to y equal to 2x. Remember what we get, where we get this 2 from? This 2 is the slope that we find up here, plus 2, which is the y-intercept. So our equation for this line then is y equal to 2x plus 2. Where you might ask, where does this 2 come from? This 2 is the slope. And if you ask, where does this 2 come from? This is the 2 we find here, the y-intercept. So you see, we now find an equation for that line. Just we were given 2 points, we were able to find the slope. We are now able to find the equation in slope-intercept form for that line, but there's more to that. We can also find the equation for that line using the point-slope form. You can find it in point-slope form, and we'll do more than that. Right? Well, after we find that, we'll also find it in slope-intercept form, going through this formula. So let's go ahead and do that. We can do it if we know one point, and we know the slope. And we do have a point on the slope. So let's go ahead. I'll use the same point here. 2x equal to 2, y equal to 6. And if we do that, the formula is y minus y sub 1 equal to m times x minus x sub 1. So then, this is what I will get. I will go ahead and replace my y sub 1 here with the 6, and my x sub 1 with the 2. And this will give me y minus 6 equal to 2 times x minus 2. And if I use the distributive rule here, I will get rid of the parentheses there, and this gives me y minus 6 equal to 2x minus 4. And now this is the equation in point-slope form. This is the equation in point-slope form, y minus 6 equal to 2x minus 4. How did I get this minus 4? Because 2 times x is 2x, 2 times minus 2 gives me minus 4. Alright, now I could now form that equation into this one that I have up here, into this one that I just found at the top here. How can I do that? By just adding a 6 to both sides, using what they call that algebraic properties of equality. It says that if you add the same number to both sides of an equation, you form an equivalent equation. So these properties are very important in all of these topics. So then I'll add a 6 here and add a 6 here, and this gives me y equal to 2x plus 2, and look what we have. We have this equation here, it's the same one that we got here. So this is, again, we get back the same equation there, y equal to 2x plus 2, going through the point-slope form equation formula. Alright, so now, when we look at this then, and we inspect this equation in slope-intercept form, this 2 here we said is the slope, which we find up here. This 2 on the back here is the y-intercept, where it crosses the y-axis. So you see now how that equation is related to the graph through these 2 points. This is a linear equation, it's a straight line. And there is your relationship. It has a slope. Now we had said that the slope is rise over run. If you start class at a point here on the line, and if you run 1 unit and you rise 2 units, you're back on the line. You run 1 and rise 2, you're back on the line. So that fits nice into our formula here for the slope of a line, rise over run. Before we go forward, any question? I want to make sure that you understand everything. Any question, feel free to ask, I will explain that. All right. So now that we have, class, our equation here, y equal to 2x plus 2, we will take that equation and write it in standard form. The formula for the standard form of the linear equation, class, is going to be this here: ax plus by equal to c, where a, b, and c are in the set of real number, and a and b are not both 0. So this is what the equation for the linear equation in standard form is going to be like: ax plus by equal to c, where a, b, and c are in the set of real number. Now, if we take y equal to 2x plus 2, which is our equation for this line, we can take this 2x over there, and then we get minus 2x plus y equal to 2, where our a is equal to minus 2, b is equal to 1 from that y, and c is equal to 2. And we see that our equation is now in the standard form. Alright? Now, let's go back here and let's look at our graph. This line here, its equation is y equal to 2x plus 2. As we said, this 2 is the slope of this line. This 2 at the back here is the y, the separated crosses the line. And we can put that in functional form as f of x equal to 2x plus 2. And these linear equations, they have a lot of this linear function. They have a lot of application in real life phenomena, real life, real world problem. So we will look more into depth in this topic and applying it to solve real world problem. So make sure you understand the concepts involved in here, and all these formulas and so on, how they are used. There's a lot of knowledge here, basic knowledge, to further study in the topic. And if you have any question, please let me know, and I will see you all next time, and we'll utilize the information we talk about on this topic. Any question? Alright, we'll see you next time.